Welcome to this 8th lecture in this series of videos on textile printing. In this video, we will talk about screen printing and inkjet printing. So in the previous lecture, we discussed block printing and roller printing, and the learning outcomes for this particular lecture include uh, to get an overview of the different screen printing processes, namely flat screen printing and rotary screen printing. However, we will focus a bit more on flat screen printing as that provides us with a basis to compare the two different types of screen printing processes. And we will, of course, very briefly cover rotary printing as well. And then towards the end of the lecture, again, I will just present an overview of inkjet printing. However, it is important to mention here that there are dedicated lectures separately on the different types of screen printing processes and a dedicated lecture on inkjet printing as well.
So let's start with screen printing. Screen printing was developed significantly in the first half of the 20th century. And if you recall roller printing, then this is the time when roller printing was the most widely used commercial technique for printing of textiles. So these major developments in screen printing process led to the replacement of roller printing processes by these screen printing methods. Currently, and when I say currently, of course, I'm referring to past few decades, like at least 5 or 6 decades, or even more than that. So screen printing for the last few decades is the most widely used method for textile printing. And just to give you an idea of how widely used method it is, then the market share of screen printing is at least 70% even today. So all the printed goods that are produced in the world, approximately at least 70% of these are produced on some sort of screen printing process. So there are two variations of the screen printing process. One is known as the flat screen printing process, and the other is known as the rotary screen printing process. And these names are uh, derived from the shape of the screen that is used. So as you will see in the following slides, that in case of a flat screen printing process, the screen is a flat mesh or a flat sheet, while in case of rotary screen printing, the screens are cylindrical, and that's why the name. So let's first talk about the printing screens, because these are very important. In fact, important enough that the printing process is named after the type of screen that is used. So a printing screen essentially is a mesh, and a mesh refers to a sheet with perforations in it. So a close-up view of this mesh would look something like this, as you can see in the image here. So this mesh could be in the flat form or in cylindrical form, as I briefly mentioned in the previous slide. If the mesh is in flat form, it's of course called a flat screen, and it looks like this. So the mesh is stretched in flat form in a rectangular frame, and the process is then called a flat screen printing process. On the other hand, if the mesh is in cylindrical form, then that screen is called a rotary screen. It looks like this. So the mesh is cylindrical in shape, and then of course the process is referred to as the rotary screen printing process. Furthermore, this mesh is converted into a printing screen or a printing stencil, as some people like to call it, by blocking a certain part of the perforations present in the surface. So you can now think of a stencil, the stencil that we use to put headings. You know that the stencil is a sheet of plastic and only the letters are sort of opened in that sheet and you can trace that opening. So more or less in a similar manner, if we block certain parts of the mesh and leave certain parts open, then it is converted into what we call a printing screen or a printing stencil. So this sealing or blocking of the perforations in the mesh is done by means of some emulsions, which are more or less like paints or resins. So when we apply this emulsion on certain areas, those areas are blocked and the print paste cannot pass through those areas, through those perforations, while the areas of the mesh on which this emulsion is not applied are open. In other words, the perforations in those parts of the mesh are open and therefore the print paste can pass through. So it might be becoming clear already that the emulsion is applied on the screen in a certain manner. So we want to leave only those areas of the screen mesh open through which we want the print paste to go through. So if you look at this image, it's a flat screen and you can see, if you take a closer look, then you can see that a certain part of the mesh is open. So this sort of perforated sheet that you see in the background is actually the mesh, and this red coating that you see is the emulsion. So the emulsion is applied in a particular pattern, and of course that pattern is according to what we want to print. So that's the emulsion coating applied on the non-design areas. Non-design areas means the areas on the fabric that we don't want to print. And this is the area in which the screen mesh is open, and so the print paste will pass through it. So how exactly we apply this emulsion on the screen and how do we create this pattern will be covered in a separate dedicated lecture which is related to screen preparation and engraving of designs on the screens. For this lecture, the sole objective is to briefly introduce the different screen printing methods. Therefore, we will leave it here and move on to other details. Now we are going to look at the flat screen printing process in a bit more detail. So as we have discussed already, that the mesh for a flat screen is a flat sheet actually. As far as the structure of this mesh is concerned, it is normally just a one by one plain woven fabric. However, the filament that is used is of hydrophobic nature. So you can imagine that if we use cotton fabric to make a screen printing mesh, then the printing ink will get absorbed in that mesh also, and that is what we don't want. Therefore, the screen mesh for flat screens is usually made up of hydrophobic filaments such as polyester. So this mesh or this fabric is properly secured in a wooden or a metallic frame. So we stretch this mesh on a frame and then by some means we secure it. Again, we are not going to discuss this in more detail because this is covered in the lectures related to screen preparation and engraving. However, I must mention here that the mesh should be stretched with very uniform tension on this frame. Otherwise, printing will not be done properly. In some cases, a metallic mesh can also be used. However, for textile printing, it's not common. For textile printing, it's almost always a one by one plain woven polyester fabric. So because the printing process depends on the characteristics of the mesh, we need to understand that what are the factors that affect the characteristics of this screen mesh. So in case of a flat screen, the mesh characteristics are dependent on the filament characteristics. For example, the strength of the polyester filament that you have used in making the mesh, the fineness of the polyester filament, that's the denier. And then because it's actually a 1 by 1 plain woven fabric, so the fabric construction, that is threads per inch, also affects the mesh characteristics. Let's discuss this in greater detail. So in these two images, you can see a 1 by 1 plain woven mesh. It's the same scale, so that's 1/10 of a centimeter for both, as you can see. However, in this image on the left hand side, you can see that there are fewer threads or filaments per centimeter or per inch. So this type of mesh will be considered a low mesh count because there are few threads. On the other hand, if you look at the mesh on the right hand side, this one, then it's a high mesh count fabric because there are more threads or filaments per centimeter of the fabric. So you can straight away see the effect of changing the mesh count, that is the threads per inch, on the characteristics of the mesh. In this case, we have less number of perforations in a given area. However, the area of each perforation or the size of each perforation is larger. In contrast, okay, so this sort of mesh is suitable for printing solid colors for blotches. When you don't want to print many fine lines or shades, then you can use this type of mesh. In contrast, in this mesh on the right hand side, in a given area of the fabric, there are greater number of perforations. However, each perforation is smaller in size. So this sort of mesh is suitable for printing of fine lines or halftones. At present, you can understand halftones as shades. So just another example of the significance of mesh count. In the image on the left hand side, you can see that the design is such that there are some solid colors in the design. There are no shades. So this sort of design can be printed using a relatively lower mesh count screen. But if you look at the printed image on the right hand side, then there are a lot of shades which we call the halftones or rasters in this print. And for this sort of print, we would need a higher mesh count screen. So let's review some of the more important characteristics of the mesh for flat screens. The first one, as we have discussed, is the mesh count. And as you have seen, it's actually the threads per inch in the fabric. And the threads per inch in turn determines the perforations or the holes per inch present in the screen fabric or screen mesh more specifically. We need the screen to have higher strength. It's also known as high modulus because a lot of forces are exerted during printing. So you will see in the later slides that during printing a squeegee is drawn on the surface of the screen with a certain pressure. So the screen mesh should be stable enough to withstand that pressure over longer time periods. We don't want the screen filament or the screen fabric to have high elongation, because if the screen mesh has high elongation, then due to the printing pressure, the mesh will eventually stretch and it will become loose in the frame, and then printing cannot be done properly. We need this screen mesh to have high tear resistance, and that is again because we want the screen mesh to withstand the repeated pressures that are exerted during printing. And of course, we need this screen mesh to have good dimensional stability. Once again, because if the fabric, if the screen mesh, which is actually a fabric, has poor dimensional stability, then you can imagine that after certain use, after using it for a certain time period, it will become distorted, and then our printing will not be as we desire. So a fact is that in industry, printers manage to reuse this mesh for up to 3 or 4 times, and that helps them in covering the cost of the screens. So you can imagine that this would have not been possible if the screens do not possess all the characteristics that are mentioned here. Let's now look at the flat screen printing process, or the steps that are involved in it. So we first have to place the fabric on a flat surface. We then place the screen on top of that fabric. We put the printing ink on the screen, and then this printing ink is dragged across the screen with the help of a scraper, which is known as a squeegee. After this, the screen is lifted and the fabric, which is now printed, is removed from the area under the screen. So all of these steps can now be seen in the animation here. So we place the fabric, lower the screen, put the ink, drag the squeegee, and then lift the screen, take out the fabric. It's a bit quick, but I'm sure you can uh, trace, you can relate all these steps that are written here with this animation. So if I do it once again, we place the fabric, lower the screen, put some ink, drag the squeegee, lift the screen, and then remove the fabric. Yeah, I did it right this time. Okay, that's the basic cycle of the screen printing process. Okay, then there are further types of the flat screen printing process, and these types are on the basis of the level of automation in the entire printing process. So the steps that you have seen, a certain number of these steps could be automated or mechanized. And then how many of these steps are automated will determine the type of the flat screen printing process. So on the basis of this factor, we have the first type of flat screen printing, which is known as the hand screen printing. We have what is known as the mechanized or semi-automatic flat screen printing process, and then a third variant, which is the fully automatic flat screen printing process. So let's talk about hand screen printing process now. In summary, in the hand screen printing process, all the steps that are involved in screen printing, or more specifically in flat screen printing, are manually done. So if you recall, the first step was to place the fabric on a flat surface. In case of hand screen printing, this is of course done manually. So the workers will spread a certain length of the fabric on a flat surface manually. The workers are then going to position the screen carefully on the fabric. This is again done manually. And then they are going to put a certain amount of ink on the screen at one side of the screen. Then they manually drag the squeegee across the screen. So that's the important process, because this is where the variation comes in. And then once the squeegee is dragged across the screen is lifted and the printed fabric is removed, or the screen is positioned on the next part of the fabric which is unprinted. These steps will become clear with the help of this nice video. So here you can see they're spreading the printing ink on the screen, and then the squeegee is dragged across the screen. Because the screen is very large, so there are two workers, one on either side. Okay, another thing that you can notice easily is that they drag the squeegee twice on the screen. This is one point that we are going to discuss about. Here they are putting the printing ink on the screen. Okay, now one thing about this particular video is that they are putting inks of different colors because they are producing a particular type of fabric. However, usually in printing, only a single color is printed from a screen, from a single screen. So they lift the screen and then they put the screen on the next unprinted patch of the fabric. And they have to position it very carefully. Otherwise, of course, the printing will not be done exactly where we require it on the fabric. So that's how the process is repeated over the entire length of the fabric. And so in the end, you get a printed fabric. Now, in this particular video, you can see that it's a relatively larger length of fabric that they are printing. However, screen printing can be done for smaller articles, for instance, a t-shirt. So whatever the type is, whether you are doing hand screen printing for larger lengths of fabric or you're doing it for t-shirts, for instance, the point is that this hand screen printing method is nowadays commercially not very significant, because as you can see very clearly that its productivity is very low. So at present it exists as a cottage industry or as a hobby instead of a commercially significant process. So as I was discussing that with this method of hand screen printing, textile articles of different sizes can be printed. So in the previous video, you saw the printers printing a larger length of the fabric, and in this case, you can see in this video over here, you can see a t-shirt being printed. So it's the same screen essentially, and the t-shirt, the article is spread flat on a surface. The screen is positioned on the t-shirt, and then the printing ink is applied on the on the screen, and then that's the squeegee. You lift the screen and there you have your printed article. So you can see the steps are the same. All the steps involved in printing are manual, but the size of the article is different. Okay, let's now talk about some major considerations in hand screen printing process. The first thing for correct printing is of course the placement of the screen on the fabric. So in case of hand screen printing, it's in a way depending on the workers on the printer to ensure that the screen is accurately positioned or placed on the unprinted fabric. If it's not done, then the print will not be deposited exactly where it is desired. And this is known as design registration. So if a print is exactly where it is desired, we say that the design registration is correct. If it's not, then we say that in the printed article there are design registration problems. The second factor to consider is that the quantity of printing ink on the screen should be as uniform as possible in every printing cycle. And that is because the quantity of ink on the screen can actually affect the print quality or the print appearance, in other words. So the workers should try to keep this as uniform as possible every time they put some ink on the screen. And the third factor, of course, is the pressure that the printer is applying on the squeegee. This pressure or this force that the printer applies on the squeegee directly dictates or determines the quantity of ink that is going through the screen. So generally speaking, in case of higher pressure, a larger quantity of ink will go through the screen. So it's totally the skill of the printer that how uniform pressure the printer is able to apply on the squeegee in every printing stroke. Let's now discuss some advantages and disadvantages of the hand screen printing process. If you have understood the process, you will understand this fact straight away that for hand screen printing, as such, we do not require any capital investment. We do not need to buy a very expensive machine or any other equipment for a hand screen printing setup. So there is virtually no capital investment involved. The process is easy. There are not too many factors to control or worry about. There are no machines, so there is no maintenance, etc. And then a very important point is that once again, in case of hand screen printing, there is virtually no limitation of the number of colors. So you can print as many colors on a fabric as you want. This is not possible in case of automated printing processes. And hand screen printing is of course suitable for short articles. By short articles, I mean shorter production runs. So perhaps you can make a note here that by articles, maybe it's not a perfectly correct term. Instead of articles, we should say short production runs. As far as the drawbacks are concerned, it's obvious from the videos that I've shown uh, that the process has very low productivity compared to the automated versions of the flat screen printing process. And then there is a slight possibility of non-uniformity of results. So if by chance a printing house appoints a worker who is not very skilled, then there are chances of non-uniformity in their prints. And due to the same factor, that is the skill of the worker, the reproducibility could be low. So let's say if today you produce a hand screen printed article in your printing house using a particular printer, then after let's say 1 year, if you repeat the same printed article, but the worker is now a different one, so it's not possible to reproduce exactly the same effect. So in summary, the hand screen printing process, if we want to do it properly, requires highly skilled labor or highly experienced labor. The second variation of the flat screen printing process is known as the mechanized or semi-automatic screen printing process. So as the name implies, this is a partially automated form of the hand screen printing process. So one of the major problems in case of hand screen printing is the pressure or the force that is applied on the squeegee by the printer. And very slight variations in that force on the squeegee can result in significant variations in the print. So to overcome this problem of variation in the squeegee pressure and the speed at which the squeegee is dragged across the screen, this particular component of the printing process is mechanized in case of mechanized screen printing. So the other processes are still manual, but only the dragging of the squeegee on the screen and the speed at which it is done are mechanized actions. So in this case, because we have removed one major source of variation, so the productivity and the accuracy is higher compared to hand screen printing. So this point is now explained in this video. So you can see the worker is going to place the fabric manually. So that step is still manual. But then the screen is lowered and the squeegee is dragged with the help of this mechanized system that you can see at the top. Once again, this, as you can see, the squeegee is not dragged by the worker. The squeegee is dragged by this mechanized system at the top of the screen. This is the cycle in which printing is done. Okay, some of you might be thinking that what is this? This is called a flooding stroke. That's the stroke in which the printing ink is spread uniformly on the surface of the screen. This has certain advantages which we are going to talk about later on. However, for now, you just need to notice that why are we calling this process a mechanized screen printing process? You can see in every cycle, the squeegee is dragged at the same speed and of course with the same pressure on the surface of the screen. That's the flooding stroke and that's the printing stroke. Printing stroke means the stroke of the squeegee in which the print paste flows through the screen. So this is mechanized screen printing process. Okay, so in the previous video, which is related to mechanized screen printing, you saw that a smaller article was being printed. So just as for hand screen printing, the mechanized screen printing can be used in different formats for smaller articles or for larger lengths of fabric. And then there are other designs also. So in this case, in case of mechanized screen printing for for large format, for larger lengths of fabric, a certain length of the fabric is placed on a printing table, just as we do in any other printing process. And then a carriage, which is carrying the screen and the squeegee system, is moved over this printing table from one point to another. And during this movement, it prints different sections of the fabric one by one. So let's look at this video to further clarify this point. So this assembly that you see here is a carriage, and it's carrying the squeegee system and the screen also. That's the squeegee system. Once again, you can see that the squeegee is being driven mechanically, so the worker is not applying any force on the squeegee. And this carriage moves over this table, as you can see here, and prints different parts of the fabric which is spread on the table already. So these are some sensors which control the movement of the carriage. That's the printing stroke. This orange frame that you see is actually the carriage. That's the entire squeegee system, which is sort of automated. That's the printing table on which the fabric is spread flat. And then of course, because it's a mechanized system, so we have some motors, we have some controls for the accurate working of the system. You can see this carriage is actually supported on wheels. That's the motor to drive the squeegee across the screen. And then of course, because it's automated to a certain extent, so we have a lot of controls. These are the systems, the levers from which we can set the squeegee pressure. So once it's set, it remains the same in every printing stroke. Okay, if we compare the two, that is the hand screen printing and the mechanized screen printing, then the major advantage of mechanized screen printing is that there is virtually no chance of variation in the squeegee pressure and the speed, because these are the two actions that have been mechanized or automated.
The drawback is that, of course, the setup cost is considerably higher. So you need to buy some equipment, and of course that equipment requires some capital investment. Right, so the third variation of the flat screen printing process is known as the fully automatic flat screen printing process. And as the name implies, the all the steps in the printing process are automated. So a recap of the steps, starting from fabric placement, and then screen lifting and lowering, the movement of the squeegee, the color supply system, all these steps are automated. And then we have a detailed lecture on flat screen printing, which will be the series 4 of the lectures. Okay, as far as the color supply system is concerned, you can see I've marked an asterisk over it. So sometimes, even in fully automated flat screen printing machines, the color supply system could be manual. Okay, this animation will help you in understanding the flat screen printing process. So the unprinted fabric is automatically placed on the flat surface. The screen is lowered and the squeegee is dragged over the screen, and then the screen is lifted. The fabric is then moved forward. It goes under the next screen. If we have multiple colors in the design, then each screen will print only one color, just as we discussed in roller printing. So the screen is lifted and the fabric goes forward. That's how it's done. So every single step that we have discussed in the flat screen printing process is automated here, and that's why it's known as the fully automatic flat screen printing machine. Let's now talk about the rotary screen printing process. So rotary screen printing is radically different from flat screen printing of any type, and that's primarily because the screens that are used are cylindrical here, and hence the name of the process. The other major difference between rotary screen printing and any type of flat screen printing process is that in case of rotary screen printing, the fabric is continuously moving while it is being printed. If you noticed, if you recall the videos and the animations for the different types of flat screen printing methods, then you can notice that the fabric is stationary while it is being printed. So that's not the case in rotary screen printing, and that's the main factor why the production rate for rotary screen printing is significantly higher compared to any type of flat screen printing process, even the fully automated type of flat screen printing process. So during printing, the screens rotate about their axis while the squeegee remains fixed at its place. So this is like a third major difference between rotary and flat screen printing processes. In case of any flat screen printing process, the squeegee is moving. The squeegee has to be dragged on the surface of the screen. But in case of rotary screen printing, the squeegee is fixed at its position, and the screen actually rotates, or the screen moves. And once again, just as for the flat screen printing process, the complete details related to rotary screen printing machine and the process controls are discussed in the lecture in the series 5 of the lectures. But for now, this animation will help you in understanding the nature of the process. So as you can see, the fabric is entering from the left side and it is continuously moving. The screens are also rotating. The speed or the surface speed of the screen and the speed at which the fabric is moving match Exactly. The squeegee is the gray is shown with the help of the gray pipe at the center of each screen. So the fabric is continuously traveling under the screens. The screens are rotating and the fabric is being printed. Right.
Let's look at a video to develop a basic understanding of the rotary screen printing machine and the process. So here in this video you can see an industrial rotary printing machine. The unprinted fabric is fed from the entry zone and passed on to the main printing zone where we have these cylindrical screens. Each color in the design is printed using a separate screen. So if you have 10 colors in the design, you will need 10 separate screens. And because the production rates are fairly high, you can see the printing speed is considerably higher. The fabric has to be dried as well. So the printed fabric leaves the main printing zone and enters into a dryer chamber. So there are different types of heads on these machines, but we are not going to talk about this right now, as we will be covering that in a separate lecture. So these are multiple identical print heads on the machine, and these days manufacturers offer us rotary printing machines with up to 36 print heads. One thing that I would like to mention is that the more colors you have in a design, the more difficult it is to control the process. This is the inside of the rotary screens. Printing ink is actually continuously pumped into the screen with the help of the squeegee holder, and the squeegee is placed inside the screen. Again, if you are not able to see those parts that I'm referring to, then you do not need to worry, as we will have a look at this in detail. Because the machine consumes large amounts of ink, and that's because it's printing fabric at a very high speed, every screen is connected to an automated color dosing system. We can adjust different parameters on the print head, such as printing pressure, positioning of the screen. So modern rotary printing machines actually allow us to print at really very high speeds while achieving a high quality of print. Let's now look at inkjet printing. This is also known as digital printing, and it is a technique which was developed about 3 decades ago, and in the last decade or so it has seen massive improvements, and so more and more printers all over the world are adopting it really very quickly.
Now, before we talk about inkjet printing, we need to understand one common characteristic of all the printing methods that we have discussed so far. So we have discussed block, roller, and screen printing methods. In all these methods, a physical image carrier or a printing plate is used to create the desired pattern on the fabric. So for instance, in case of block printing, it's the block which is a physical object carrying the image that we want to print. So that's called the image carrier or the printing plate. In case of copper roller printing, it's the copper roller itself which is carrying the image. So the copper roller is the printing plate for roller printing process. In case of screen printing, it's either the flat screen or the rotary screen on which we create the image with the help of an emulsion, as you saw in the earlier slides. So the flat screen or the rotary screen is the image carrier or the printing plate in case of screen printing methods. So all these things, the block, the copper roller, the flat screen or the rotary screen, these are physical objects carrying the image. So that's called the printing plate or the image carriers. These are so the use of this physical printing plate has certain drawbacks, The first one is that of course it has a certain cost. If you want to make the screens, then of course you have to buy the screens. Those are relatively expensive. We discussed in roller printing that the copper rollers are very expensive to produce. Blocks are not that expensive, but if you're using high quality wood to produce those blocks, then cost could be one factor there as well. So this this cost of the printing plate is one major drawback of all these printing processes that we have discussed so far. The other problem that originates is the resolution. So for instance, we can produce blocks of certain fineness. Even with the most skilled worker, it is possible to produce fine designs, but of course there are limits to that as well. So due to this printing plate, the resolution could be limited. And then it's the third problem related to use of these physical printing plates is that of handling. So the screens that we have seen, the flat screens or the rotary screens, these are very delicate, and often in handling these screens are damaged, and so you have to incur some extra cost for that. And then storage issues. We discussed in roller printing that a printer usually would like to store these copper rollers or the blocks or the screens. So in case of repeat order, we don't have to produce them again. So of course, they need a large storage space in that sense. So keeping these factors in mind, if you talk about inkjet printing, then the desired image or the print on the fabric is produced by jetting droplets of ink directly on the substrate surface. So there is no physical printing plate present in case of inkjet printing, and therefore all of the problems that are listed here at the top of this slide are eliminated immediately, just because of the fact that a printing plate does not exist in case of inkjet printing. So that's the reason why inkjet printing is also known as non-impact printing, because a physical printing plate does not exist, and therefore nothing is actually coming in contact with the fabric to produce the print. In case of block, the block has to be pressed onto the fabric, so there is physical contact between the fabric and the block. Same is applicable for roller printing as well, and then for screen printing also, the screen touches the surface of the fabric during printing. In case of inkjet printing, there is no physical plate, so there is no physical contact of anything with the fabric. That's why it's called non-impact printing process. So in order to understand how an inkjet printing process works, you can consider the example of an inkjet printer that you might have at your home or you have seen at some point in your life. So we just put a paper, unprinted paper, at the back of the printer, and then we send the design that we want to print or the text that we want to print to the printer directly with the help of a software. And the ink droplets are jetted onto the paper directly, and the print is produced. So this is a rather old technology. Inkjet printers for papers are around for at least 3 decades or even more than that. So for obvious advantages of inkjet printing, this method has been developed for textile printing also. So just to get an idea, you can say in a sense that the inkjet printing for textiles works in more or less exactly the same way as it does for paper. So once again, we are going to comprehensively discuss about inkjet printing in a separate series of lectures for inkjet printing.
Let's watch a short video of inkjet printing. So here you can see that just as we open any file on a computer, we open the design file on a computer and send it to the printer, the machine directly. So one of the major advantages is that the design file is directly transferred to the machine. You can have a certain range of different colors of inks on the machine, but CMYK will always be there, and more colors are added to increase the color gamut of the machine. The heart of the machine is what we call the head, and this is from where ink droplets are directly sprayed onto the fabric. So you can see that the print head is traversing from right side to left side and then back, and as it moves over the fabric, it sprays the droplets of ink directly on the locations where they are required. You probably have already realized that this looks very similar to an inkjet printer that we use for our household applications and in our offices, and this is exactly what it is actually. So an inkjet printer for textiles is just an enhanced domestic inkjet printer basically. So your design is directly printed onto the fabric without any intermediate steps such as preparation of any printing plate or screens, as we call them in case of screen printing. Let's now look at a summary of what we have covered in this video. So we have understood that printing screens are essentially a mesh. In other words, it's a sheet with tiny perforations in it. And what we do is we block the non-design areas of this mesh using an emulsion. As a result, the print paste can only pass through the areas or through the perforations where the mesh is open. These are also known as the design areas. We have seen that screens for printing are of two types, flat screens and rotary screens. And this is what gives the two screen printing processes their names. Flat screens are essentially a woven fabric, and depending upon the extent of automation, flat screen printing could be classified as hand screen printing or manual screen printing. This process has virtually no automation in it, and all the printing steps are carried out by hand. The second type of flat screen printing process is what is known as mechanized flat screen printing, also known as semi-automatic flat screen printing. And this has partial automation in it, which means that some of the steps in the printing cycle are automated or mechanized. And then the third type, which is known as the fully automatic flat screen printing machine or printing process, one in which all the printing steps are mechanized or automated. These are the machines that are used in large scale printing industry for producing several hundreds and several thousands of meters of fabric every day. Then looked at rotary printing briefly, and the major difference to note at this stage is to understand that in rotary printing the fabric is continuously moving while being printed. This is not the case in any of the flat screen processes that we have discussed. And this is the reason why rotary screen printing process has generally higher production rates compared to any type of flat screen printing process. Lastly, we have briefly looked at inkjet printing technique, which is completely different from all the printing techniques that we have studied, and it is one in which a permanent printing plate or printing master is not used, and printing is done by jetting droplets of ink directly onto the fabric at desired locations. That's all for this lecture. Thank you for your attention, and I hope that you're looking forward to studying rotary screen printing and different types of flat screen printing processes in more detail.